In the ancient world of science, Greeks pioneered philosophy. The philosophy at that time is different from today, as science was part of their philosophy. The Greeks were brilliant. They thought about a lot of things and gave explanations to phenomena. However, a lot of their discoveries are wrong. Do you remember the geocentric model of the universe developed by Ptolemy of Alexandria in the 2nd century CE? Ptolemy believed in the geocentric universe. It was his explanation about the movement of the sky, and according to him, the sun, moon, stars, and planets all orbit the Earth. There was also this Aristotelian view of science, which states that you just need to reason and no need for experiments. An example of this would be from Aristotle himself. According to him, everything in the world is made up of 4 elements: earth, fire, air, and water. And from these elements, you can already figure out why some things happen. Without any experiments, he concluded that heavier objects fall faster because they have more earth in them. However, is it true? Let's try to look at this video.
Para sa experiment na to, meron ako ditong bato at papel. Alin nga ba sa dalawang ito ang unang mahuhulog? Tingnan natin.
Nonetheless, this Aristotelian view dominated for 2,000 years, until mid-1500s, when Nicolaus Copernicus overturned Ptolemy's geocentric model with his very own heliocentric model of the universe, a cosmological model in which the sun is assumed to lie at or near a central point of the solar system, while the Earth and other bodies revolve around it. Also, when Galileo Galilei discredited Aristotle's idea that heavy objects fall proportionally faster than lighter objects, by proving that force was not necessary for motion in his experiment called the Leaning Tower of Pisa. This period was called the Scientific Revolution.
Thomas Kuhn. Thomas Kuhn is an American historian of science. He was born at July 18, 1922 in Cincinnati, Ohio, U.S. He lived for 73 years and died at June 17, 1996 in Cambridge, Mass. Aside from being a historian, he is also a philosopher and a trained physicist. He was most known for his work, The Structure of Scientific Revolutions. Thomas Kuhn began his academic career in physics. He subsequently went to science history, and as his career progressed, he moved on to science philosophy, while still maintaining a strong interest in physics history. He received his Harvard summa cum laude diploma in 1943. Following that, he spent the rest of the 4 years at Harvard and later in Europe conducting radar research. In 1946, he received his master's degree in physics, and in 1949, he received his doctorate in physics. Kuhn was also inducted into Harvard's renowned Society of Fellows, which also included W. V. Quinn, who is also a renowned philosopher. In the late 1950s and early 1960s, Kuhn taught a class in science for undergraduates in humanities at Harvard. Yun yung first opportunity niya to study historical scientific texts in detail. However, Kuhn was confused. Aristotle and other Greeks are brilliant. So why are they so wrong about the basics of science? Eventually, na-realize niya na he was looking in the wrong way. Katulad ng mga illustrations, the understanding of the picture depends on the point where a person is standing and looking at the object. His confusion upon reading Aristotle's scientific works was formative experience, followed by a more or less immediate capacity to interpret Aristotle properly, unaffected by the future scientific understanding. Aristotle was not wrong in his view. It just does not follow the science we knew today.
And in 1962, Kuhn shared this discovery through the book The Structure of Scientific Revolutions. This book is about the history of science. In it, Kuhn argued that different sciences undergo revolutions when scientists gather enough data that they cannot explain anymore using their current paradigm or unstated world organizing theory about how the universe works. In The Structure of Scientific Revolutions, Kuhn paints a picture of the development of science in an entirely new way. Indeed, there was little in the way of a well-considered, theoretically explained account of scientific change before Kuhn. Instead, there existed a popular, heroic image of scientific development, as well as a conception of how science should grow that was a byproduct of the prevailing philosophy of science. According to these viewpoints, science progresses through the addition of new truths to the stock of existing truths, the increasing proximity of hypothesis to the truth, and on rare occasions, the correction of past errors. While development may be accelerated in the hands of a particularly brilliant scientist, the scientific process guarantees progress. These ideas of Kuhn have animated a lot of debates in the history and philosophy of science. So, what is then the structure of scientific revolutions? First, let's define a scientific community. A scientific community cannot practice its trade without some set of received beliefs. These beliefs form the foundation of the educational initiation that prepares and licenses the student for professional practice. The nature of the rigorous and rigid preparation helps ensure that the received beliefs exert a deep hold on the student's mind. According to Kuhn, there are two types of sciences: the normal science and the extraordinary science, also known as the revolutionary science. And according to him, the progression of science is not linear, but alternates between normal and extraordinary phases. Extraordinary or revolutionary periods are not just periods of rapid growth. They are essentially different from normal science. On the surface, normal science resembles the typical cumulative picture of scientific development. So let's discuss these two types of sciences further, starting with the normal science.
Normal science. Normal science according kay Kuhn ay puzzle solving. While yung term na ito nag-imply na normal science is not dramatic, yung main purpose niya is to convey the idea that like someone solving a crossword puzzle, a chess problem, or a jigsaw puzzle, the puzzle solver expects to have a reasonable chance of succeeding, and that his success will be based primarily on his own abilities, and that the puzzle and its method of solution will be very familiar. A puzzle solver isn't venturing into unknown terrain. Normal science may anticipate collecting an increasing supply of puzzle solutions since its puzzles and answers are known and relatively simple. Yung existence ng strong network of commitment, which is conceptual, theoretical, instrumental, and methodological, ay yung nagpipicture sa normal science as puzzle solving. Dahil provided na yung rules na nagsasabi sa practitioner kung paano yung world and science niya, nakakapag-focus siya ng may assurance sa mga problema na dinedefine na ng mga rules and existing knowledge para sa kanya. Bali yung gagawin niya na lang ay mag-iisip kung paano bubuuin yung natirang puzzle. Normal science can also be viewed as a collection of stacks of books, wherein there are textbooks describing the observations, theories, and laws that are taught to students in schools. The science in this body of knowledge is simply a constellation of facts, theories, and methods that are contained in those textbooks and in the way they're taught. The contributions of great scientists are part of the stockpile of knowledge. Science, in this view, is cumulative. Discoveries are added to the pile on top of others. Kuhn's argument in the structure of scientific revolutions concentrates a significant portion of its attention on one particular component of the disciplinary matrix. When Kuhn employs the term paradigm in a narrower meaning, he refers to these examples of good science. As paradigms, he offers Aristotle's study of motion, Ptolemy's planetary computations, and Lavoisier's application of the balance, in which Lavoisier wrote that, in the balance, nothing is lost, everything transforms, mass is neither created nor destroyed. Na kung naalala niyo pa is yung law of conservation of mass, and Maxwell's mathematization of the electromagnetic field, kung saan na-notice ni Maxwell na yung electric field and magnetic field can be combined to form electromagnetic waves. Exemplary scientific instances are generally found in books and articles. Hence, Kuhn frequently refers to great literature as paradigms. Such texts include not only the key theories and laws, but also application of those theories to the solution of important problems, as well as the new experimental or mathematical techniques, such as the chemical balance in elementary treatise on chemistry and calculus in Principia Mathematica, or mathematical principles of natural philosophy, using those applications, and this is what distinguishes them as paradigms. In other words, approaches, laws, theories, methods of application, tools, and machines are all part of a paradigm. It is a web of facts and assumptions that all function together. Pwede siyang i-refer as a pattern or a model. So if we say that paradigms are like this, then masasabi din natin na normal science is based on existing paradigms. Kuhn's paradigm provides a map whose features are revealed through mature scientific study. And because nature is far too rich and varied to be examined at random, that map is as important to science's continued evolution as observation and experiment. Paradigms appear to be essential to research activities because of the theories they embody. However, sometimes, puzzle pieces don't fit. Existing knowledge or theories are found to be wrong or incorrect. And so, there exist anomalies. which may lead to crisis once not corrected. Therefore, yung mga paradigms ay kailangang i-challenge or abandonahin. As Thomas Kuhn claimed, observations do not exist in a vacuum. They are instead enclosed within a theory. A theory is a narrative that explains the importance or meaning of the observations. A paradigm is the prevailing theory in any discipline at any particular moment, and the observations are made within the framework of that paradigm. When observations are produced that do not fit within the paradigm, a difficulty arises. When too many of these findings do not fit within the previous paradigms, a crisis occurs. This signals the start of extraordinary science.
Extraordinary science, the second type of science according to Kuhn. Here, Kuhn explains that extraordinary science are not cumulative, because they entail a revision of current scientific belief or practice. This is because in the extraordinary science, more experimentation, debate about other fundamentals, and research, which is according to him a strenuous and devoted attempt to force nature into the conceptual boxes supplied by the professional education, happens. These further experimentations, debates, and research might lead to revolution. In a revolution, not all of the achievements of the previous time of normal science are maintained, and a later period of science may find itself without an explanation for a phenomenon that was thought to be effectively described in a previous period. The phenomenon known as Kuhn loss, the term to have been coined by Heinz Post, is a paradigm's or theory's loss of its predecessor's ability to offer explanation in a certain posit-solving domain, then leads to paradigm shift. Which is described by Kuhn as scientific revolutions. The tradition-shattering complements the tradition-bound activity of normal science. The world may be viewed as a collection of facts, which is one way to view scientific development. These facts can be seen and added to previous observations. As a result, advancement appears to be an additive process. So what is this paradigm shift? Actually, this is the point of Kuhn's book. So according to him, a shift in professional commitments to shared assumptions takes place when an anomaly subverts the existing tradition of scientific practice. And so, two things then happened. First, new assumptions, paradigms, or theories require the reconstruction of prior assumptions and the re-evaluation of prior facts. This is difficult and time-consuming. That is why it is strongly resisted by the established community. Second, when a shift takes place, a scientist's world is qualitatively transformed and quantitatively enriched by fundamental novelties of either fact or theory. So how does paradigm shift happen? Let's now look at Kuhn's model. Pre-science is where all new fields begin. It is where they begin to have a particular attention in a problem area, but it cannot be solved or no progress is made. When a model of understanding, or what we call paradigm, is made, the field will be able to progress smoothly and find discoveries on its central issue. This is the normal science phase, and in this phase, the paradigm will most likely stay the longest. Over time, the field delves so deeply into its subject that it uncovers new issues, or what we call anomalies, that its present paradigm is unable to answer. The paradigm becomes weaker as more of these anomalies arise. This is the model drift phase. The model crisis phase is reached when there are enough unanswered anomalies that the paradigm cannot be patched up to explain them. The paradigm is clearly incapable of handling the field's present concerns of relevance in this case. It's a crisis because reasonable decision-making is no longer possible. Instead, you'll have to rely on guesswork and intuition, which are more likely to fail. Finally, one or more viable possibilities emerge from the battle to construct a new model of understanding. And so here, we see the extraordinary science, which is the first step in the model revolution. The new model is a new paradigm, hence it's a scientific revolution. It's fundamentally opposed to the old paradigm, so much so that the two are incompatible. Each employs its own set of criteria to assess the other. As a result, practitioners in each paradigm are unable to converse effectively. This leads to resistance to paradigm shifts. The paradigm shift process begins once a single new paradigm has been agreed upon by a few influential advocates or the scientific community. The field is transitioning from the old to the new paradigm while also maturing the new paradigm. The previous paradigm is eventually replaced to the stage when the field's new normal science emerges. Because our understanding of the world is never full, the cycle repeats continuously. Let's now delve deeper to the two chapters of this book, Chapter 6 and Chapter 13.
Chapter 6: Anomaly and the Emergence of Scientific Discovery. This chapter traces paradigm changes that result from discovery brought about by encounters with anomaly. But first, ano nga ba yung anomaly? An anomaly is a puzzle or problem a scientist cannot solve using the existing paradigm. According kay Kuhn, yung anomaly is a violation of the paradigm-induced expectations that govern normal science. Anomalies are detected through empirical analysis and have formed the basis for most discoveries in the natural sciences. A scientific community's insularity would appear to restrict the kind of transformation that leads to a new paradigm. The fact that science does not strive for unique or new theories is further proof that new paradigms should not emerge from scientific research. Kuhn, on the other hand, has already said that anomalies occur naturally in the path of science. He also claims that they are frequently overlooked, disregarded, or dismissed. Not only that, but scientists continue to discover fresh data and propose radical new theories regularly. That is through scientific research, new and unsuspected phenomena are uncovered. As a result, paradigm shifts are possible. So, how does a paradigm change come about? Paano nga ba nagkakaroon ng paradigm change? So, according kay Kuhn, may dalawang ways na posibleng mangyari yon. First is through discovery, and second is through invention. First, paradigm change through discovery. According kay Kuhn, it is the novelty of fact. Awareness of an anomaly begins with the process of discovery, with the recognition that nature has somehow violated the paradigm-induced expectations that govern normal science. Perceiving an anomaly is essential for perceiving novelty, although the first does not always lead to the second, in which anomalies can be ignored, denied, or unacknowledged. After recognizing the anomaly, its area is then explored. Kuhn writes, when, for these reasons or others like them, an anomaly comes to seem more than just another puzzle of normal science, the transition to crisis and extraordinary science has begun. The anomaly itself now comes to be more generally recognized as such by the profession. More and more attention is devoted to it by more and more of the field's most eminent men. Then, paradigm change is complete, when the paradigm or theory has been adjusted so that the anomalies become the expected. As a result, scientists is able to see nature in a different way. Discovery involves an extended process of conceptual assimilation, but assimilating new information does not always lead to paradigm change. An example is the discovery of oxygen in the 18th century, kung saan nag-start ito ng revolution sa chemistry. Before kasi yung pinapaniwalaan nila is yung Aristotelian view of science, kung saan mayroon lang 4 distinct elements, which is yung fire, air, water, and earth. Bali, yung leading theory na nag-grow mula doon ay yung phlogiston theory. Sa phlogiston theory, sinasabi niya na combustible materials contain phlogistons, which allows them to burn, and phlogiston is released when they burn. However, when ore is heated and transformed into metal, bumibigat siya. For the most part, this anomaly was overlooked or explained away as phlogiston passing from the coal to the metal. When metal rusted, the phlogiston could be seen leaving it. However, this created a new issue. Rusted metal increases weight, and mas mabigat siya kumpara sa normal na metal. So once again, because it couldn't be solved with the pieces of the puzzle provided by the existing phlogiston paradigm, it was generally ignored. Two things slowly come together to cause a problem. The discovery of pneumatic chemistry, which employed equipments like air pumps to compress air and see the effects of gases, increased the precision and importance of employing weights. These air pumps allowed you to burn things while seeing air escape. It indicated that the phlogiston theory was being pushed to its limits. It couldn't answer more and more problems. So, two chemists, Joseph Priestley from England and Antoine Lavoisier from France, conducted groundbreaking experiments kung saan nagsusunod sila ng iba't ibang materials and then they measured the results. So, yung experiments nila ay parang ganito. But with a more complicated equipment. So, nag-burn sila ng iba't ibang materials in a vacuum and then they weigh the products. Yung idea, according kay Kuhn, ay in a massively intricate world, what you focus on and the techniques and instruments that you use makes a significant difference in the results. In a massively intricate world, what you focus on and the techniques and instruments that you use make a significant difference on the results. Kung babalikan natin yung discovery of oxygen, you would see how an experimental and conceptual elements were used by the two scientists, and kung paano nag-differ yung results na nakuha nila. Futility of panning it down to the discovery at a certain point of by means of a simple act. Mahalaga ding tandaan na discovery is an extended episode with a regularly repeating pattern, rather than a one-time occurrence. Confirmation is restricted. Kapag walang confirmation, existing paradigms could still be studied further. Hence, anomalies can still be observed. And kapag yung mga anomalies na ito arise, revolutionary science can then take place. And magkakaroon ng shifting paradigms. Sa shifting paradigms, a new and improved paradigm or idea may be achieved. Next is the paradigm change through invention. Kuhn described it as the novelty of theory. Unanticipated outcomes derived from theoretical studies can lead to the perception of an anomaly and the awareness of novelty. Yung well-known example nito is yung discovery of X-rays. Wilhelm Röntgen's discovery occurred accidentally in his first book in Manila, where he was testing whether cathode rays could pass through glass when he noticed a glow coming from a nearby chemically coated screen. He dubbed the rays that caused this glow X-rays because of their unknown nature. Perception. There will be no paradigm change if there is a resistance to anomaly. Siyempre, walang mangyayaring paradigm change kung hindi nila i-acknowledge yung anomaly. walang magbabago dun sa existing na science. Anomaly appears only against the background of the provided paradigm. The more accurate and broad the paradigm, the more sensitive it is to detecting and generating change. A paradigm that resists change ensures that anomalies that lead to paradigm shifts penetrate current knowledge to the core. If you read the page 2, 3, 15, and 52, you can observe that Kuhn is being careful of his use of discovery and creation in science. The point of this chapter is that the distinction between discovery and invention, or between fact and theory, will, however, immediately prove to be exceedingly artificial.
Let's now move to Chapter 13. Progress through Revolutions. In the face of the arguments made all throughout the previous chapters of this book, Kuhn answers the questions: why does science progress? How does it progress, and what is the nature of its progress? In this last chapter, Chapter 13. In answering these questions, Kuhn explains these two: the identity and goal of science. So first, we need to know the identity of science because perhaps progress is inherent in the definition of it. As according to Kuhn, we tend to see as a science any field in which progress is marked. So the question here: what makes science a science? Does a field make progress because it is a science, or is it a science because it makes progress? If you try to read this chapter, you'll see that Kuhn points out the reality that to a very great extent, the term science is reserved for fields that do progress in obvious ways, and this issue is of particular import to the social sciences. So here Kuhn asks, is a social science a science because it defines itself as a science in terms of possessing certain characteristics and aims to make progress? Next, he also says that a scientific discipline gains a strong sense of identity when there is an agreement within the community on past and present accomplishments, pointing out that questions about whether a field or a discipline is a science will cease to be a source of concern not when a definition is found, but when the groups that now doubt their own status achieve consensus about their past and present accomplishments. Here, Kuhn asks once again, do economists worry less than educators about whether their field is a science because economists know what a science is? Or is it economics about which they agree? Also, he asks, why do not natural scientists or artists worry about the definition of the term, about what makes science a science? Pero, ano nga ba ang manifestations of progress? According to Kuhn, there are 4 manifestations of progress. First, the result of successful creative work. For no creative school recognizes a category of work that is, on the one hand, a creative success, but is not, on the other hand, an addition to the collective achievement of the group. Even if we argue that the field does not make progress, that does not mean that an individual school or discipline within that field does not. The man who argues that philosophy has made no progress emphasizes that there are still Aristotelians, not that Aristotelianism has failed to progress. In addition to this, Kuhn states that in the arts, progress has also occurred as representations became more realistic with refinements in instruments and techniques of the artist. Second, solving the problems or puzzles that scientific communities' paradigms define. Third, Revolutions close with a total victory for one of the two opposing camps. When it repudiates a paradigm, a scientific community simultaneously renounces most of the books and articles in which that paradigm had been embodied. Fourth, paradigm change. As we have seen, this perception is, in important respects, self-fulfilling. Now that we know a scientific discipline gains a strong sense of identity when there is an agreement within the community on past and present accomplishments, let's try to answer the question, why does science progress? The answer: normal science progresses because the enterprise shares certain salient characteristics. Members of a mature scientific community work from a single paradigm or from a closely related set. And so while working, nagkakaintindihan sila, nakaka-relate sila sa isa't isa, kaya possible na mapag-usapan nila yung mga nakikita nilang mga mali or pwede pang ma-improve sa existing paradigm nila para mas maging maayos pa ito. Also, it is very rarely do different scientific communities investigate the same problems. Kasi nga, hindi sila belong sa isang scientific community, and so walang agreement sa pagitan nila. Kaya hindi sila magkakasundo at magkakaintindihan sa pag-aaral ng iisang paradigm. Let's move to the second question. How does science progress? The answer: through revolutions. And to explain this, babalikan natin yung Kuhn's model na natakal na natin kanina. Here's the model. Ngayon naman, let's explain this by starting with the cause of revolutions, and that is an anomaly. Sa diagram na ito, makikita ang anomaly sa model drift phase. So when an anomaly is observed, further research occurs. Pero diba sa pag-research, pwede mas maraming anomalya ang lumitaw na hindi na kayang sagutin ng existing paradigm. And so magre-result ito sa crisis. Na sa diagram na ito makikita sa model crisis phase. Ngayon, let's move to the model revolution phase na may unang step which is the extraordinary science, kung saan dito nangyayari ang further experiments, debates, and researches. And in researching, a new paradigm is then offered. Ito na ang tinatawag nating scientific revolution. And if this new paradigm contains the observations better than the old paradigm, then there is a paradigm shift. Take note, however, that the paradigm shift will only occur when the scientific community embraces it. And they will just embrace it when, number one, the new paradigm is seen to resolve some outstanding and generally recognized problem that can be met in no other way. And number two, the new paradigm promises to preserve a relatively large part of the concrete problem-solving ability that has accrued to science through its predecessors. Kapag natanggap na ng scientific community ang new paradigm, magkakaroon ng paradigm shift. And so the old hypothesis is then demolished, and the new paradigm takes its place. Scientific progress, according to Kuhn, is as much about destruction, especially demolition of the old paradigm, as it is about adding new findings. Even this new paradigm will only survive until it is thrown into a crisis of its own. Ibig sabihin, never-ending ang cycle na ito because hanggang may anomalies na nag-a-arise sa existing paradigm, patuloy ang pag-solve sa anomalies na ito. Kaya naman, patuloy ang pag-ikot ng Kuhn's model. Now that we have answered the first two questions, we move to the goal of science. So according to Kuhn, although science progresses, it does not progress towards a specific goal. Why? The explanation of Kuhn for this statement is based on Charles Darwin's theory of the origin of the species. For him, science progresses because there are occurrences of change. However, these changes are not bound to accomplish a set objective because everything just changes in response to stimuli, which is the anomaly in this case. For example, Men had to adapt to their changing environment. Hence is the need for them to change their walking from 4 legs to only 2 legs. While this shows progress, this was not something that was undertaken to reach a certain walking position goal. In fact, according to Darwin's theory, people could continually evolve their way of walking when the need for adaptation arises. Similarly, science would continue to change as long as an opportunity for change, which is an anomaly, arises. At dahil alam na natin ang identity and goal of science, nabalikan na rin natin yung Kuhn's model, masasagot na natin ngayon yung third question. What is the nature or cause of science's progress? The answer: anomalies. Without the observance of anomalies, revolutions, which is the manifestation of progress, could not take place. Sabi nga ni Kuhn, progress is also a salient feature of extraordinary science, during a revolution. Kanina nasabi ko na ang cycle sa Kuhn's model ay patuloy na iikot hanggang may anomalies na nakikita sa existing paradigms. Dito na papasok ang kakaibang perspective ni Kuhn about truth. Sabi niya, we may have to relinquish the notion, explicit or implicit, that changes of paradigm carry scientists and those who learn from them closer and closer to the truth. In this statement, Kuhn denies that science is constantly approaching the truth. Actually, at the end of his book, he asserted that science, like life on Earth, does not evolve toward anything, but only away from something. This is because Kuhn believes that our paradigms keep changing as our culture changes. According to him, different groups and the same group at different times can have different experiences and therefore, in some sense, live in different worlds. Dahil sa kanyang perspective na ito about truth, sa dulo ng kanyang book, may iniwang tanong si Kuhn. Sabi niya, what must the world be like for us to know it? At kami namang Group 11, ang tanong namin sa inyo ay, if paradigms are just different perceptions or views about the world, at sabi ni Kuhn, ito ay palaging nagbabago at patuloy na nagbabago, then, does that mean that there is no truth?